Today in Algebra 1B we're going to focus on factoring. And the factoring that we're going to worry about really has to do with the fact when this value that a is a value that's greater than 1. Now in order to solve these problems we are going to use the same things we were doing before in 9.5. So case 1, case 2, case 3, case 4, all those things are going to be alike. Also in this section we are going to also have to worry about thinking about if something has the greatest common factor that you can pull out. So you should always do the greatest common factor first if it does exist. And we'll see a couple examples of those today. So let's take a look at our first problem. The first problem we have is 6n squared plus 23n plus 7. Now this problem does not have a greatest common factor. It doesn't have a number that I could take out of each one of these. So that means I'm just going to start out like I did on the other problems. If I know it's a plus plus, that means it's going to be a case 1. Also means that it's going to be a sum of 23. If it is a case 1, then if I take these parentheses and set them up down here, I know that these are both going to be n plus and n plus. Now on this problem, I want you to kind of be aware that I've left room in front of these n's to actually write a number, because whatever these two numbers are going to have to multiply together to give me that 6. Now there are times when I give you some hints as to how to solve these that are completely non-mathematical. This is one of them. If you have a number that's in front of the variable squared, whatever it is, and it's a number other than 1, then we're going to draw brackets here. I actually refer to these as the evil clown. Hope you can see the evil clown face that's there. This bracketing is really meant to help you pair up things in the right way. Those of you that use FOIL to be able to multiply your things out before, these would consider to be the outside and inside terms. If you're someone who's been using the shortcut method, these actually come from the two numbers in the middle column that you total together. So we're going to keep working on that. The other thing that we're going to do in this section is if it's in standard form, we are going to factor both the first number and the last. So 6 is going to factor to 1 and 6, and 2 and 3. 7 is going to factor to 1 and 7. So when I'm trying to think about how to put these together, 1 and 7 I don't have any choice about. But when I'm looking at these, I want to choose the pair that's the closest together as far as values. Or even think about it on a number line. 2 and 3 are closer to each other on a number line than 1 and 6 would be. So I'm going to start with 2 and 3. And I want to be able to pair these up so I get a sum of 23. So that means if I pair up the 3 and 7, that's going to be 21. When I multiply them together, and 2 and 1 when I pair them together is going to give me 2. So really what they want us to be able to say is they want to know, sorry, I'm going to try to write this up a little higher so you can see it better. They want to know that the two numbers that you have here and here are going to give me a sum of 23, which they do. So now, when you have a case 1 or a case 2, the nice thing is, because they both have the same plus signs, or in the terms of case 2, they both have minus signs, I know these 1 and 7 are going to have to be things that stand by themselves at the end. So I can just fill in the 1 and 7. No need to worry about placement because they're both pluses. But if you take the 7 pairs up with a 3 here, which means the 7 is going to pair up with a 3 here. Then the 1 pairs up with a 2, and the 1 pairs up with a 2. Now also the big deal in this one is that 2 and 3 are the numbers that have to go with n, so that's right, those are there. And the 1 and 7 are numbers that have to stand alone because they have to give you the 7 at the end of your fraction, or excuse me, of your trinomial. So this 1 and 7 would have to be on their own. Now, if I were doing this and I wasn't sure if I multiplied right or not, the easiest way to do this would be actually to do 3n plus 1 times 2n plus 7 and make sure that when you're done, you get 6n squared plus 23n plus 7. You want to make sure that you can actually go and get that value from it. If you can't, you know you better back it up and figure out what you did wrong. Okay, let's take a look at another one. Okay, on this problem I have 18k squared minus 12k minus 6. And if I look at those, I can already tell that I know it's got a greatest common factor of 6. So I'm going to go through and do what we did early in chapter 6 and actually pull that 6 out. So 18 divided by 6 is 3. 12 divided by 6 is 2. And 6 divided by 6 is 1. Now the good thing is, when you get to this point, it's much easier to factor and do everything because the numbers are smaller. So if I go to do this now, if I have a minus minus, that means I have a case 3 with a difference of negative 2. So if it is case 3, that means that down here, one of these is going to be plus, and one of these is going to be minus. Now a couple things that we need to do. We need to make sure that that 6 comes down and is out here. And then I'm going to add my evil clown. And if I go back up here, the two numbers I'm going to factor are 3 and 1. Now the good thing is, because the way they're actually factored, because they're prime, they only have one pair apiece. So if I'm trying to put these together, that's going to give me 3. And this is going to give me 1. So 3 and 1 are going to give me a difference of 2. If I want that difference to be negative, then this number has to be negative, and this one has to be positive. Because negative 3 plus 1 would give me negative 2. But the only thing is, these signs are great, but they have to go on these numbers because they're the only ones that are going to be down here after a plus or minus. Actually, what it's going to do is it's going to help us locate where they belong. So I'm going to go to this negative 3 that I have, and I'm going to put a negative there. This is what touches the positive one. I'm going to put that there. So the plus 1 goes here, and the plus 1 is hooked to 1. So the plus 1 is hooked to 1. On this one I have a minus 1 that's hooked to 3, and at the end of this there's your 3. Now when you go to write this, most people will probably drop that 1 that's in front of the K from up here, but either way is okay. You just have to make sure that you know that there's a 1 there, whether you assume it's there or not. Okay, let's try one more, if we can get one more in before our time is up. Okay, in this problem, factor 20x squared plus 17x plus 3. So I can tell by looking at these, no greatest common factor at all. And I would go ahead and start figuring out my path here. So it's a case 1, which means it has a sum of 17. And if it's a case 1, then down here, do our brackets, and I'm going to factor 20 and factor 3. So the 3 is the easiest. 20 has a couple more factors. Now remember, when I do this, I usually want to start with the pair that's the closest together in value, which would be 4 and 5. And 1 and 3, I don't have any choice about that. So if I go to pair these up, 4 times 3 would be 12. 5 times 1 would be 5. And 12 and 5 would give me a sum of 17. Now again, we have a little bit easier placement on this because these are both plus signs. So the 1 and the 3 are just going to have to go after those plus signs. Now 1 hooks to the 5, 1 hooks to the 5. 3 hooks to the 4, and 3 hooks to the 4. Oops. And that means that this part right here is going to be your final answer.